Okay, so in this video, what we're going to do is we're going to talk about the difference between what's known as long division and synthetic division. As you can tell, I have a little quick definition of what long division is. We just use to divide and find factors. You've been using long division since your middle school days or elementary school days, however you want to call it, right? Your teacher would ask, how many times does 3 go into 36? And you would say, oh, well, 3 goes into 3 one time. Put the one at top. You'd multiply these numbers together and you would subtract, right? Obviously, 3 is not going to go into 0, so you bring down that 6. So 3 goes into 6 two times. So what did this tell you? This would tell you that 3 goes in evenly into 36. So 3 would be a factor of 36. Okay. It also tells us that 12 is also a factor of 36, right? Because I can multiply these two numbers together and ultimately get 36. You don't have to worry about copying this down. That's fine. But if you think about 5 goes into 81, now in your head you would say no. But we can still divide 5 into 81. So you would ask yourself, what number do I multiply 5 by to get close to 8? That'd be 1. So 1 times 5 just gives us 5. And then we subtract, bringing us a 3. Bring down the 1. And 5 times 6 would give us 30. And we get a remainder of 1, right? A little r next to that remainder. So depending on the year that you learned a long division, this might have been an answer. You might have written it as 16 and 1/5 as well. Oops, because the 1 doesn't go in even, or the 5 doesn't go in evenly into the 1. So we're going to use that knowledge to divide polynomials with each other. And ultimately, we are trying to figure out, is this binomial or the trinomial a factor of the polynomial? And we're going to start with an easy one of the trinomial x squared plus 3x plus 5. And I want to know, is x plus 1 a factor, right? So I just want to divide that out, right? So I'm going to set it up exactly how I kind of set up these initial problems. So the x plus 1, right, is our divisor. So that's going to go on the outside. And the trinomial x squared plus 3x plus 5 is going to go underneath the long division sign. And so, again, you're going to focus on the first number since it might be a binomial or a trinomial. You don't want to focus on all of the numbers following, but just the x. Okay. And again, you're going to ask yourself, what do you multiply x by in order to get that number? Because again, we want to cancel it out, just like we wanted to cancel out that 3 at the very beginning. So you might be thinking to yourself, oh, well, an x times an x will give me an x squared. So I put an x on top. And this is really what you're doing. You're multiplying that x by the x plus 1, that binomial. And so what do you get? You get x squared plus x. Notice that the x squareds are underneath each other. The x's are underneath each other. And then we go ahead and we subtract. Now, when we subtract, right, unlike these problems up here where there was just one single term, notice that I have two terms. So I really want to change everything that used to be positive. I want to change both of those to a negative sign, right? You might see some people putting parentheses around the whole thing and just a negative on the outside. It doesn't matter. But ultimately, you're subtracting. These terms will always cancel out. Boom, they're gone. And then 3 minus 1 leaves you with 2x. Bring down the plus 5, so don't forget the positive with that 5. And again, ask yourself, what do you multiply x by in order to get that to become a 2x? Hopefully you all said a positive 2, so we're going to put a positive 2 there. And then again, I'm going to multiply a positive 2 by that x plus 1. And we're going to multiply that 2x out. And 2 times 1 just gives us a positive 2. And you're looking at this problem and thinking, well, I know that the 2x's will cancel out when I subtract those, but the 5 and the 2 will not, leaving you with a 3, right? So this is your remainder. Now, there's several ways that I can kind of write my answer. Okay, this is the answer that I'm looking for, x plus 2. It's our figuring out how many times does x plus 1 go into this trinomial. So I'm going to start with x plus 2, and which is this is our quotient, right? Which we'll identify on my next page. And then I want to add my remainder, right? My remainder is a positive, so I have a remainder. And I notice that the 3 is not going to go in evenly into my divisor. So I'm just going to put that divisor underneath it. And I have x plus 1. And so this is the correct answer. Notice we didn't get a remainder of 0, which means that this is not a factor. Okay, so ultimately, what is this? Okay, what kind of problem is this? This is leading us to what's known as the division algorithm. You're going to want to pause this video and kind of copy this down. So it says f of x and d of x are just polynomials such that your d of x cannot equal 0. And the reason why it can't equal 0 is because if I multiply these two numbers together, then that will go away. And if I divide the f of x by d of x, right, that can't happen. I can't have 0. The degree of the d of x is less than or equal to the degree of f of x. Okay, so notice that on our last example, example number 1, bringing this back, all right, we notice that we have an x squared. So this would be technically our f of x. You can think of it that way. And then this would be our d of x. Think of it that way. Okay, so notice x squared, x. So this is less than your f of x. That's just what that's saying. Okay, and so there exists a unique polynomial. We'll call that q of x. That's our quotient and our remainder. Sometimes we have a remainder, sometimes we don't, such that this is true. Okay, so our f of x is our dividend, d of x is our divisor, quotient is our is what is the leftover part, and then the remainder is what is at the bottom of our long division. Essentially, this is what happens, right? I'm dividing my d of x into my f of x. And so if I divide all of this by d of x, right, that's why the d of x is gone. And that's why the r of x remainder has the d of x in the denominator. That's the only reason why you see this. You'll also see this in your book on page 117. So you might want to look that up in case you have any questions. But before we kind of apply the algorithm, we want to do the following. We want to make sure that we write both the dividend and the divisor, so both the f of x and the d of x, in decreasing powers of the variable. So if it starts with x squared, we're going to say x squared to x to your constant. If we start with a higher power, right, 5, then we'll go 5, 4, 3, 2, 1, 0. And then what we want to do is we want to insert placeholders with 0 coefficients for any missing powers of that variable. This is really, really important because if we don't do that, right, we could potentially get a wrong answer. So make sure that you take a special note about that. So if we take a look back at this first example, I should say, notice that it goes powers of 2 to 1 to none, right? Power of 1 to none. So again, they're all in decreasing powers, and we're not missing any terms, so we don't see a 0. Okay. But if we look at our second example, we do see stuff that's missing. Notice it goes from a power of 3 in the numerator to your constant term. So we're missing definitely some variables. And it goes from a power of 1 to a power of 0 in our denominator. So that's okay. So we can keep our denominator the same. So 2x minus 1. But in the numerator, what I'm going to do is I'm going to write placeholders. So I don't have an x squared, so it becomes a 0x squared. I don't have a linear term, so it becomes a plus 0x, but I do have a constant term, so that's okay. All right, and again, we want to set it up using long division, so I'll say 2x minus 1, and then put our divisor underneath the long division symbol. Okay, you'll also realize when I was talking about how the x squareds go underneath each other, the x's go underneath each other. If you don't remember the placeholders, you're not going to have a place for all your terms, essentially. Okay, again, start with the 2x. What do you multiply 2x by to get to an 8x cubed? That would be a 4x squared, right? 4 times 2 gives you 8x cubed, and 4x squared times negative 1 will leave you with a minus 4x squared. Again, notice that they're still underneath each other, right? Negative, positive. So your x cubed will cancel out, and a positive 4x squared plus 0 will leave you with a 4x squared. Bring down the 0x, and we're going to repeat this process one more time. So again, what do you multiply 2x by to get to that term? Plus 2x. So this will leave you with a 4x squared minus 2x. One more time. Negative, and two negatives will make that positive. Boom, boom. So the 4x's will cancel out. 0 plus 2 is 2x. And we bring this down. Now notice that this is the same as that term. So hopefully in your head you're thinking that it goes in evenly. It does. So plus 1. So this will be a 2x minus 1. Again, negative, positive. That cancels away, and that will also cancel away. So you're going to be left with a remainder of 0. So what is our answer? Our answer is that number right there. Oops, pencil broke. 4x squared plus 2x plus the number 1. Okay, a little bit different than what we wrote here, right? If we didn't have a remainder, right? If we had a remainder, I should say, then we would write it very similar to this problem. All right. So what I want you to do is I want you to pause the video and try this one. I know this one looks a little bit more challenging, right? But it has, because it has a lot more terms. But notice I have 4, 3, 2, 1, 0, so you don't have to worry about placing a 0 placeholder. And same thing on the denominator. It's a trinomial, but you're going to set it up just like the binomial. So pause it, take a look how you did. All right, so you should have set the problem up like this. So minus 1, 6x to the power 4, minus x cubed minus x squared, plus 9x minus 3. And again, I'm going to focus on that x squared. So what do I have to multiply that to get to 6? So that'll be a 6, and then exponent rules would be x squared. So multiply these together, so this becomes 6x to the power 4, and x times x squared, so this will be a positive 6x cubed, and then a minus 6x squared. That will turn negative, that will also turn negative, but that one will turn positive. So cancel those out, negative and negative, so minus 7x cubed, and 6 minus 1 will leave you with a positive 5x squared. Bring down that positive, bring down that positive 9x, and we're going to do this one more time. All right, so again, x squared times what gives you a negative 7x cubed, so minus 7x. And notice that your quotient is also decreasing, so it's not going to be squared and then another squared. All right, so that kind of little things will help you along the way. So minus 7x cubed minus 7x squared, positive 7x. And go ahead, change that to a positive, change that to a positive, but that one turns to a negative this time. So what's going to happen? Boom, those cancel out. 7 plus, or 5 plus 7, I should say, should be 12x squared, and 9 minus 7 leaves you with a positive 2x. Bring down that 3, minus 3. All right, so again, one more time. What do you multiply x squared by to get to 12x squared? That will be a 12. Oops, can't really read that. Let me write that better. There you go. So positive 12x squared, and then a positive 12x, and then a minus 12, negative, negative, positive. So what happens? Those cancel out. 2 minus 12 leaves you with a negative 10x, and negative 3 plus 12 should leave you with a positive 9. All right, so notice now this degree is larger than this degree. So it goes back to your d of x. You want to keep using the division algorithm if your f of x polynomial, right, this polynomial is equal to or larger than your divisor. So right now it's not. So this is all my remainder. So my answer is written like this. Plus negative 10x plus 9 all over x squared plus, oops, can't really see that, sorry. Right? So again, remember this is my quotient, so this is my answer. So I'll write this out so you guys can see this. So this is my quotient. I spelled quotient right. So that's my quotient. That is my remainder. And this is my divisor. Okay, so if I multiply this answer, right, or if I set this equation back equal to what I originally started off with, and then I multiply everything by x squared plus x minus 1, I will get my original numerator, my f of x. That's essentially it. Okay, again, if you have questions, please email me, and I'll get back to you hopefully right away. Now, with long division, the key word in that is that it's long, right? So there are some problems that you have to use long division for. For example, our example 3 and our example 2, you should have used long division for it. But there is an easier method, and we're going to talk about that right now. So this is known as synthetic division. It is what I like to call a shortcut when dividing polynomials of the form x minus k. All right, so notice that the x does not have a coefficient, right, except for 1. It's a positive x as well. Notice that it has no exponent. So if you have a problem that has a divisor that is a binomial, so just a single term, then you get to use this synthetic division. So we're going to pretend, right, we have this long, what's the word I'm looking for? Our dividend, right? And this is our divisor. And we don't have any numbers, we're just letters, okay? So what's gonna happen is you're gonna kind of create this backwards L. And you're gonna solve for your divisor. So if I just set x minus k equal to 0, and I solve for it, I'm gonna get x is equal to k. So I'm gonna put that k value on the outside of this this like backward, this L, I should say. And then what I'm gonna do is I'm gonna take just the coefficients, right? A, B, C, and D, right? So these are your coefficients. So coefficients of the dividend. Okay? Again, if there's a negative number, then obviously we would put a negative sign with like the B, the C, whatever those numbers are. If something's missing, right? Even though it's the division algorithm, we used it first with long division, we can also use it with the synthetic division, right? We would put placeholders. It'll be very important here. Okay, so there are two patterns going on. There's a vertical pattern and a diagonal pattern. Okay, so the first thing that you're going to do is understand what the patterns are. So the vertical pattern, so what's happening up and down, is basically this. You are just adding terms. Okay, and the diagonal pattern, I should say, is you are going to multiply by k. Those are the two things. So the first thing you're going to do before you start off this pattern is you're going to bring down your A. So you're going to bring it down underneath your line. And that's when the pattern's going to start. You'll multiply the A by the K, and you're going to get AK. Oops, pencil broke again. And then what are you going to do? These are just going to be numbers. You're going to add these two numbers up. So it's going to be whatever B plus AK is. And then you're going to repeat this process, multiply these two numbers, add them up. Multiply these numbers, add them up. And at the end, this last box right under D, that is going to be your R, which is your remainder. Okay? Any numbers that you get underneath this synthetic division, this L shape, these will become your new coefficients. So coefficients of your quotient. And your quotient is always one less than what you started off with, right? Because it kind of goes with your exponent rules, right? If I divide x cubed by just an x, right, I really am subtracting a 3 by 1, which would give me 2. Okay, so it looks a little complicated when we don't have numbers, so let's see what happens with our first example. Okay, so I'm going to use synthetic division to divide this polynomial by this one. All right, so take a moment to copy that down. You might have to pause it. So the first thing I am going to do is I'm going to take my divisor and I'm going to set it equal to 0, right? So I'm going to get x is equal to a -3. So -3 on the outside. And then I'm going to take my coefficient. So I have a power of 4, so this is a coefficient of 1. Power of 3, notice I don't have a power of 3, so what do I have to add? You're right, a 0. Power of 3, power of 2 is a -10. Power of 1 is a -2. And then I have a 4. And my last column, I always like to have a box there, so that way I know that that's my remainder, right? So that's my remainder. Ultimately, what do I want? I want a remainder of 0, right? So let's see what this problem now looks like. Bring down the 1, so we don't have to do anything. So I got 1. So 1 times a -3 is going to give you -3. Add these two columns together, right? So I get -3. Then what do? I multiply those numbers together. That's your diagonal pattern, right? Vertical pattern means that we're going to add, so that gives you a -1. Diagonal pattern, multiply those two numbers together, +3. Vertical pattern tells me I'm going to add those numbers together, 1. Multiply with the diagonal pattern, I have a -3. And then finally add, and I have a 1. We got a remainder, so this did not go in evenly into our polynomial, which is fine, right? But our new answer will 1 less than what we started off with, so this will become a 1x cubed. And then these are just your new coefficients. So this is x cubed, so this will be squared, your linear, and then your constant term. So -3x squared minus x plus 1. And then with our remainder, add that and use your divisor, x plus 3. Right? And you got your answer. Notice how quick that was. If we stopped and we did it long division, you're still going to get the same answer. It's just long. It'll take you a little bit longer. All right. So let's try one more like this. So go ahead and if you want to pause it, try it on your own. Great. But again, we're going to use synthetic division. So take this, set it equal to 0. I'm going to get -2. Long division. So set my coefficient. So power 3, 2, 1, 0. I don't have to have a placeholder, which is perfect. So there are all my coefficients. What do? I bring down my 5 and multiply those two numbers together. I get a -10. Add them up. -2, +4, a 3, -6. I forgot my box at the beginning. And I get a 0. It is a remainder of 0, which means that this is a factor of my polynomial. All right, so what's my answer? 5x squared, right? Because I go 1 less than what we start off with, minus 2x, and then plus 3. So the coefficients are always 1 less than what you start off with. So what's the ultimate reason I'm asking you guys to do long division and synthetic division, right? It's ultimately this. We use either form to find the zeros of a polynomial function and to graph it, right? We're going to talk about, when I get back, the P's and Q's. How do we actually find those factors of like how do we know that -2 was a factor and things like that. But ultimately, it's to find all of our zeros and to graph, right? What we talked about in the previous video. Okay, so go ahead and practice your long division and synthetic division. And if you have any questions, ask each other or email me, and hopefully I will help explain it. All right, have a great night.